3 to the power 2n plus 2 is there. Therefore, I first write 2n plus 2 into 3 square. Pm true. We have now shown Pm plus 1 is true. Therefore, Pm plus 1 is true. RHS equal to 1 by 2 plus 1, 1 by 3. Now we see these two are equal. Therefore, LHS equal to RHS. Therefore, the immediate comment will be, therefore, P2 is true. Welcome to btosacademy. Welcome to my maths class. Today, in the first part, I shall work out few sums of mathematical induction. I have taken the first sum, this one. 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. As discussed earlier, first of all, we take the mathematical statement. Let Pn 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. In the first part, we shall verify for n equal to 1. 3 to the power 2n plus 2 minus 8n minus 9 is equal to 3 to the power 4 minus 8 into 1 minus 9. Let us calculate. This is 81 minus 17, that is equal to 64. This is naturally divisible by, which is divisible by 64. Therefore, P1 is true. Thus, we have verified this expression is divisible by 64 for n equal to 1. Now, let Pn be true. That is, just we replace n by m. 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. Now, in the next step, we shall show Pm plus 1 is true. Now, this is divisible by 64. Therefore, I can take this is equal to 64k. 3 to the power 2n plus 2 minus 8n minus 9 equal to 64k, where k is any natural number. And here we mention n greater than 1, n is natural number. Now, taking this, we shall show Pn plus 1 is true. For Pn m plus 1 the expression is equal to 3 to the power 2 m plus 1. We are replacing m by m plus 1 plus 2 minus 8 m plus 1 minus 9. Just we have replaced m by m plus 1. Now we shall show step by step. This is also divisible by 64. Now this can be written as 3 to the power 2n, 2 plus 2, that is 3, 2 plus 2, 4, it will be 4, minus 8n minus 8 minus 9. Now 2n plus 2, here 3 to the power 2n plus 2 is there, therefore I first write 2n plus 2 into 3 square minus 8m minus 70. Now in the next step I shall write 17 as difference of 18 and 1. Is equal to 3 to the power 2m plus 2 into 9 minus 18 minus I can write also 9 plus 8. If I write 9 plus 8, then 9 will be common factor. 9 plus 8. Now, taking these two together, 9 will be common factor. 3 to the power 2m plus 2 minus 1 minus 8m minus 8. Now from here 3 to the power 2 to 2m plus 2 minus 1. If I write 9 as 8 plus 1, 3 to the power 2m plus 2 minus 1 will be equal to 64k plus 8m minus plus 8. I have kept minus 1 here, remaining minus 8 I have taken that on the right side. Therefore, in place of this part, I can replace this one. That is equal to 9 within brackets 64k plus 8m plus 8 minus 8m minus 8. Now I simplify. 9 into 64k plus 72m plus 72 minus 8n minus 8. Now 9, I put this symbol, into 64k plus 64m plus 64. What we find, 64 is the common factor. We take it outside, 9k plus m plus 1. After assuming Pm to be true, I have taken this one as multiple of 64 and then this step. Now for Pm plus 1, I have proceeded in this way, and finally we see this is a factor of 64. Why? Because this one as 9k plus m plus 1 is a natural number. Then next step will be assuming Pm true. We have now shown Pm plus 1 is true. Therefore, Pm plus 1 is true. Therefore, by PMI, Pn is true, where n belongs to set of natural number. Next final statement. Therefore, 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. One thing to mention, I have taken here 64k, and keeping in mind this one is divisible, we can also write 3 to the power 2n plus 2 minus 8n minus 9. We can keep these two also on the left side. Following that, we also arrive in the same result. Therefore, finally, this is divisible by 64 root. Now, second sum. Left hand side, product of 1 minus half, 1 minus 1/3, 1 minus 1 by 4 dot dot dot, 1 minus 1 by n plus 1, and right side is 1 by n plus 1. Now first we notice the left hand expression is product. Therefore, in this case, we have to start by taking two terms first. That means in this case we have to start taking n equal to 2. Follow that this is product. Therefore, we cannot say we take n equal to 1. In that case, if we take n equal to 1, that means only one term will be. Therefore, no case of product. That is why we are to take here the least value n equal to 2. Let as it is. This is the mathematical statement Pn 1 minus half, 1 minus 1/3, 1 minus 1/4, dot dot dot, 1 minus 1 by n plus 1 is equal to this. N belongs to set of natural number. As the left hand expression is a product of numbers, here groups actually. That is why basic step will be P2. This is the reason students, learners, note this, why the basic step will be P2 as it is product. I have explained that within the third brackets. Now for n equal to 2, LHS will be, that means two terms or two groups, 1 minus half into 1 minus 1 by 3, that is equal to half into 2 by 3, finally 1 by 3. RHS equal to 1 by 2 plus 1, 1 by 3. Now we see these two are equal, therefore LHS equal to RHS. Therefore the immediate comment will be, therefore P2 is true. Next, let Pm be true, that is 1 minus half, 1 minus 1 by 3, 1 minus 1 by m plus 1 is equal to 1 by for P m plus 1. LHS will be 1 minus half, 1 minus 1/3, 1 minus 1 by m plus 1. Now up to this, about Pm, for Pm plus 1, one factor will be increased, that is 1 minus 1 by m plus 2. We have to replace this m by m plus 1. After simplification it will be 1 by m plus 2. Now up to this result already we have written, therefore LHS will be equal to 1 by m plus 1 into this one. We simplify that, it will be m plus 2 minus 1 divided by m plus 2. After simplifying, this is m plus 1, means m plus 1 by these two are cancelled. Final result is 1 by m plus 2. Now for m factors, result is this one. Then for m plus 1 factor, m plus 2, which is obtained by replacing m by m plus 1. In LHS of, I have taken this relation as A. Now if I replace m by a plus 1, we shall get this one. Therefore, comment is P m plus 1 is true. Therefore, final step, by PMI, principle of mathematical induction, Pn is true. After that, we shall write that final step. Therefore, 1 minus half, 1 minus 1/3, 1 minus 1 by 4, dot dot dot, 1 minus 1 by n plus 1 is equal to 1 by n plus 1. Proved. Thus, second sum is finished. Third sum, left hand side you see is 1 into factorial 1 plus 2 into factorial 2 plus 3 into factorial 3 plus dot 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 plus n into factorial n. Though I have not yet discussed factorial matter, just let me discuss that factorial symbol. Actually, factorial matter is discussed in the topic permutation and combination. As I have not discussed permutation and combination, just I discuss here the symbol and what is the definition or meaning of that symbol. Factorial symbol. Symbol is factorial, say R, or the other one is second one, note of exclamation type symbol. Now, meaning of R factorial. Meaning or value, this is 1 into 2 into 3 up to R. Product of successive numbers starting from 1 to R, that is factorial R. Also we can write in the reverse order, or R into R minus 1, R minus 2, dot 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 3 into 2 into 1. R factorial is this one. When I shall discuss permutation combination, we shall, or I will discuss in detail more results. Now Keeping in mind this meaning, we progress. Let Pn 1 into 1 factorial 2 into 2 factorial plus 3 into 3 factorial plus n into n factorial is equal to factorial n plus 1 minus 1. For P1 LHS, that means only first term 1 into factorial 1, that is equal to 1, and RHS is equal to factorial 2 minus 1. The factorial 2 means 2 into 1 minus 1. After simplification it will be 1. Therefore, we see LHS, RHS both are same. P1 is true. Now, inductive step, inductive hypothesis. Let Pk be true where k greater than 1, k is natural number. I suggest students you follow the steps strictly. I have seen in various books, according to me, steps are not done properly. That is why I am discussing the problems stepwise. Therefore, 1 into factorial 1 plus 2 into factorial 2 plus 3 into factorial 3 plus k into factorial k equal to factorial k plus 1 minus 1. For p k plus 1, LHS will be 1 into factorial 1, 2 into factorial 2 plus 3 into factorial 3 plus k into factorial k plus next term is k plus 1 into factorial k plus 1. Now, up to this, we have assumed this one, that is equal to, you may put brackets also like this. Then this will be factorial k plus 1 minus 1 plus this one plus k plus 1 factorial k plus 1. Now I take these two terms together, and what we find, k plus 1 factorial is common factor, then k plus 1 plus 1 whole into factorial k plus 1 minus 1. Now the result will be k plus 2 into factorial k plus 1, k plus 2 factorial k plus 1 minus 1, and this is factorial k plus 2 minus 1. Now let us recall factorial r plus 1, factorial r is this one. Now we can make the result r plus 1 factorial. That is how much? It will be 1 into 2 into 3 into r plus 1. Now this is 1 into 2 into 3 dot 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 into r. Next r plus 1. Actually r is there before r plus 1, therefore we can write like this, and this is nothing but factorial r into r plus 1. Therefore if I get r plus 1 into factorial r, I can write easily this is factorial r plus 1. This sense is used here. From this, the immediate conclusion is P k plus 1 is true. You see, that is of the form this one, only k has been replaced by k plus 1. Therefore, we are now going to finish this one. Therefore, by principle of mathematical induction, Pn is true, that is 1 into factorial 1 plus 2 into factorial 2 plus 3 into factorial 3 plus dot 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 plus n into factorial n is equal to factorial n plus 1 minus 1, where n is a natural number. The sum is finished.